to Meet the PI, presented by Animal Behaviour Live. In this podcast, we sit down with leading researchers to explore their research journey, the challenge they faced, and advice for the next generation.
Welcome everyone to our new Animal Behavior Live Meet the PI podcast. In each episode of podcast, we'll shine a spotlight on eminent researchers in the field of animal behavior. Our goal is to go beyond the science itself and to explore the people behind the researcher, how they build their career, the twist and turn along the way, and the challenge that may faced during their career, as well as the inspiration that guided them. The idea with this podcast is that some member of the ABL team will discuss with a PI. And so today I will be the one chairing this session. I'm Alexis Buatois, a researcher and scientist at IAVAG in Switzerland, working on ecotoxicology and learning in memory in zebrafish. And today I will be joined by David Michaelskey, a retired computer programmer in UK, and Tang Vodon, group leader at the University of Queensland, Australia, working on development of insect machine hybrid robot. As I say, all part of Animal Behavior Live. For our first event, we are thrilled to introduce Dr. Amir Patel. Please tell me if I don't say correctly.
It's fine. Perfect.
Welcome, Amir. Amir is a new associate professor at the University College London in the Department of Computer Science and the driving force behind the African Robotic Unit, a group of robotic researchers at the University of Cape Town. Amir's work is at the crossroads of robotics and animal behavior, actually. He has been inspired by cheetah speed and agility to design new kind of robots. And more recently, he's using robotics and AI to monitor the health of wild animals like lions. His career journey is just as exciting as his research, and we are really looking forward to diving into this story. Amir, your career path is pretty inspiring for many of us because you earned your bachelor in mechatronics in 2009. And after some time as a flight control engineer, you came back to the University of Cape Town to start your PhD, where you use robotics to understand the locomotion of animals. And so, based on that, the first question that will come is that what drove you to make this move? Was there a pivotal moment or mentor that shaped your path, for instance?
Well, it's a good question, yeah. So, thanks for such a great introduction and sort of giving my background, because I think a lot of people don't know that I was sort of after graduating from my bachelor's, I was involved in aerospace and focused on flight control and doing a lot of aircraft analysis. That was sort of my main thing. I even did my master's thesis on collision avoidance for fixed wing aircraft. But I've always had a fascination my entire life actually on animals, but also like dinosaurs. I was really excited about dinosaurs as a child. But then I kind of got into robotics and very, very keen on that. But then I got offered a position at the University of Cape Town to do my PhD, but then also to be an assistant lecturer. And my immediate, because at the time I was working in aerospace, my immediate thing was, cool, I'm going to do some kind of aircraft thing. I'm going to stick with what I know. It's going to be, that'll be the safer route. And then I remember I stumbled upon a TED talk by Professor Bob Fall at UC Berkeley it was about geckos and how they use their tails to kind of like flip around. And he was showing how you could describe that motion with a PD controller, and they built a robot to understand that. And I just found that so fascinating that you could use techniques from engineering and robotics to highlight and understand animals. I just found that very fascinating. So I kind of became obsessed with with this idea. And I spoke to one of my colleagues, a good friend of mine now, Robin Verinder at the University of Cape Town, to say I'm interested in this, and I really like the idea of tails, because around 2012, tails in robotics it's quite a hot topic because everyone was trying to put a tail on their robot. And then she said, "Oh, have you seen like cheetahs? Like, and in Cape Town, we have many breeding centers. You can see cheetahs very easily." Um, and then I said, "Yeah." And she said, "No, have you seen their tails? Like they flick their tails." And I thought, okay, awesome. That's my PhD. I'm gonna build a robot that uses a tail like a cheetah. And then during this process, I thought, I'm going to start off and I'm going to use lots of biological data, lots of studies and models to, inform the design of my robot. And then I very quickly realized that there actually wasn't much known about the tail, besides, sort of anecdotes of people saying, oh, it uses it as a rudder, uses it as a counterweight, things like that. And then I thought, whoa, okay, what do I do now? And then I thought, okay, I can use techniques from robotics to actually understand and provide insight to biology. And that's kind of how I've, set, I guess that's like 13 years ago now. And I've kind of been running with that idea and using the cheetah as a sort of model animal for understanding, maneuverability. So yeah, that's kind of my journey so
Okay,
far.
yeah, that's very nice. But like, yeah, can we expect to see some dinosaur robot at some point, maybe? Like to come back to the actual roots of what you liked.
Oh man, I would love to, honestly. Like I just, yeah, haven't. If I had more time, I would definitely do it. I've been trying to get into it. But yeah, no, I find it's fascinating. I've seen some like work on people doing open some optimal control to, show how Tyrannosaurus Rex would have like run. And I just find that like that kind of stuff so cool. So yeah, maybe.
And so that when it came to this decision to actually switch from more engineering to actually like link robotic and biology, like did you have the feeling that it was a hard decision? Like did you had some fear about the fact that maybe it will be hard to find your place here?
Yeah, 100%. So I think at that time in University of Cape Town, like things were very siloed. So at the moment, it was everyone like the older professors kind of didn't see the value in it, and they were like, no, you write IEEE transactions, that's, write a journal there. They didn't even see the value of conferences, which is another discussion. Um, but yeah, I remember like getting a lot of pushback and people not quite understanding, like, yeah, like what is this engineering? Like this isn't like and they always kind of the feeling was that you're going to sit in the middle and not be like enough of a biologist or enough of an engineer. And yeah, it has been tough sometimes, like so submitting to like ICRO, IROS, like robotics conferences, and then they think and they're like, oh, like, what is the applications for this? Or similarly on a biology front, doing it, submitting a paper there and not quite landing. So I think it's like quite a fine line, but there are people I think like that are doing, this very well. So I think Auke Espert in DPFL does this amazingly. Like, he kind of he sits in that line where you can talk to biologists and he does amazing robotics engineering. So I think definitely like one of the people I look up to. Um, but yeah, definitely a challenge. But I think, after when I left University of Cape Town, in a permanent role after 12 years. But during that time, I established I co-founded, I should say, the African Robotics Unit. Um, and, I'm very proud to say that we were often like the only African, institution at these like top robotics conferences. And we did get publications in IEEE transactions on robotics, that, traditional engineering outlets, and then also got patents on technologies, because I often tell people like I think like studying animal biomechanics is kind of like a space race in a way, because it's like these very difficult problems that you need to come and innovate and create new engineering techniques actually to study. So, as an example, many of my systems have become patents because they are applicable to, biomedical engineering or sports science. Like we actually have a spin out company, which does measuring 3D force because it's something that I wanted to do on cheetahs, but needed to think of a cheaper way to do it. So yeah, I think yeah, definitely see that as yeah, an interesting way that it can, spread across different fields.
Going back to your PhD,
Yeah.
what did you find out about what the
Yeah.
cheetah's tail was for?
Yeah, no, thanks for that question. Yeah. So I found so there's two stories. I guess the one is so I built a robotic car with a tail, and I would say about 75% of my thesis was us using the car as a physical model to understand the different motions that we saw from videos. So we saw the cheetah do, I would say, three primary motions. The one was like a motion in the roll axis, and that's the classic. If you Google cheetah turning, you'll see the cheetah like turning and then it flicks its tail in the roll axis. And we discovered that that motion helps stabilize the body. And it does that with sort of like using an inertial effect. And then we did a similar thing with deceleration because we also saw in many videos that when the cheetahs like suddenly like brake, they flick their tail in the pitch axis. And that also helps. If you imagine if you're riding on a bicycle and you suddenly like lock your front wheel, you'll end up tumbling. So a similar thing there. And then we also did some very cool thing where we saw in a couple of videos the cheetah kind of swung its tail in a combination of pitching and yawing, sort of in like a conical motion during longer duration turns. And we did a mathematical optimization on just a mechanical model of a tail to generate roll torque on the body, and that actually was the motion that came out. So that was quite cool. So we did a lot of like robotics work. So many of that stuff was published in, like I said, like IROS and ICRA, which are like our top robotics conference proceedings, and then also in like journals and so on. But then about like towards the end of my PhD, I got invited to a cheetah autopsy at one of the zoos in Pretoria. And up until this point, like there wasn't any like data on how heavy is the tail? What inertia does it have? How much musculature does it have to actually flick the tail? So I was very keen, I'm an engineer, so this was like very new to me. And I went to this autopsy and was very surprised by what I saw. So basically, I'm sure many of you have seen a cheetah's tail. It's like on the videos, it's quite like fat, right? And when we took off the fur, it was actually just like really skinny and very low inertia. Like most of the inertia, most of the mass was down at the bottom, so there was a lot of muscle for actuating it. But the tail itself, like, wasn't actually this high inertia appendage that I had kind of like based my entire thesis on. So I was a bit like panicked and worried. Um, but then I got this crazy idea that what if, because the cheetah's moving at such high speeds, like could it be using aerodynamic effects, so aerodynamic drag to actually, use that for stabilization. So imagine, if you're driving in a car, you put your hand out to the window, you can feel that like massive amount of force, and that force scales quadratically. So what we did was a pretty crazy thing is we got a couple of cheetah tail pelts and we put them in a wind tunnel. And we actually discovered that um, the cheetah tail can generate like up to 40% more angular impulse because of this aerodynamic effect. So that's the effective is like if it had a much heavier tail actually. So it kind of gains that without having to carry around this massive weight. And it makes sense because everything about the cheetah is sort of optimized for like weight reduction and speed and agility. That why would it want to carry around this like really heavy thing when it can just leverage the speed that it's actually moving at. So yeah, that was quite a surprising discovery, and that we actually ended up being in a biology journal, which I was quite proud of. But yeah, so that was kind of my PhD in a nutshell.
So
And
it's bringing all sorts of different disciplines in. So you're bringing the veterinary science, you're bringing in aerodynamics, the engineering background, the animal
Yeah.
mechanics. That's fascinating.
Yeah.
And I think it's cool to remind here for people who are listening the podcast that if you are really interested about hearing more about the work of Amir, like that there will be a talk during the conference, the ABL conference. So like, do not hesitate to actually come and attend because it's free. So and I'm sure that it will be amazing to hear about it.
Mm.
Yeah, I just wanted to kind of follow up on what you were saying about the fact that you had this feeling at the beginning that there was a sort of blocking from maybe the oldest generation of PI. And I was wondering if it's still something that you are observing or if maybe like with like this raising of AI, raising of like I mean of technology nowadays, like you have the feeling that it's easier to go with this type of topic, even in terms of funding search, for instance, because I believe that since you are in a crossover between biology and robotics, maybe sometimes in terms of funding scheme, it's a little bit complex.
Mm. Yeah, I know it is a bit complex, yeah. So I mean, I should say that I was lucky in South Africa that I was very generously supported by the National Research Foundation, and they saw a lot of value in it, and that I was producing outputs, and I should say the government there is also very pro transformation. So there's kind of a drive to transform I should say, the demographic of academia in South Africa. So there's a lot of like funding calls in place. They support like young, we call them like previously disadvantaged people. So that was very helpful. And then also I should say, surprising to me is that a lot of big tech companies actually saw value in this. So some of my work was funded by Google, and in South Africa at the time, Google said it was a small gift, but the amount of money was like quite big for us, and sort of like sustained the group for a good couple of years. And then also MathWorks has been a great partner of the research. Um, because yeah, it's a good story, I think also is, like using robotics to, understand wildlife. So we also, I think aiding conservation in a sense, and providing insight to this, amazing animal that's, any kid, if they know about cheetahs, and it's this sort of tangible thing of seeing science in action. So I also like do a lot of outreach work and speaking at like, schools and primary schools and high schools, and it always resonates with students because they can see, oh, this is, centrifugal force will make the cheetah fall over. That's pretty cool. And then I see the same thing in the robot. Like, so yeah, definitely has been, I should say, much better. Also, since joining, I've been at UCL now for a year, and I should say the UK is a lot less siloed than in South Africa. I mean, so in the compute, I'm in computer science at UCL, and they are just like these psychologists, these neuroscientists, like for all in the same. Because I mean, even myself, I was like a bit scared to even apply for that job because I didn't think that I was a computer scientist. But I'm using computing in my research, and that sort of like, makes me tick the box. So yeah, I don't think that there's that much constraints on like, staying in your lane. Yeah.
Okay, yeah, thanks. Maybe Tang, like you wanted to.
Yeah, I think it's really nice up here. So your research span from the inspiration from the tail to now transition to sport application as you mentioned. Can you tell us a bit about how you can get the inspiration from the device that you use for cheetah and then now translate it to like sport application?
Oh, to the sport application.
Yeah.
Yeah, so kind of like just after my PhD, one of the things that like kind of like stuck in the back of my mind is, we're doing all this like physical modeling of robots, and mathematical modeling, but we actually still don't know what the real animal is doing. And Alan Wilson's group at Royal Veterinary College did some amazing stuff with collars, and the collars are awesome because it's just like one thing around the neck, and you can kind of leave it, and you get lots and lots of data. But the problem with a GPS collar is you just kind of you reduce the animal from this thing of all the articulation of its legs and spine and tail. You lose all of that. It just becomes like one lumped rigid mass, and you
Mm.
can tell how that thing is moving, but you don't know like how it was able to move in that way. So I kind of went on this journey of trying to see how can we measure what the real animal is doing. So the first thing we did was we developed this on-animal motion capture system where we put a harness on some captive cheetahs, and we had some cameras that like kind of like looked out the back. So the cameras were on the cheetah, and
Mm.
we could reconstruct the spine and the tail with this, and it worked like on quite a few cheetahs. Like we got a cool paper out of it, but eventually the cheetahs, like they were it was too cumbersome for them. But the cool thing is we actually got a patent out of this because some of my colleagues at sports science, um, we developed an IMU um, time synchronization system through this project. And they thought,
Mm.
oh, this is really cool. Like, for sports science, we could, capture, at much higher accuracy with the system. And then the other thing that was, yeah, really surprising was I um I wanted to measure. So after a couple of years, I've been doing kinematics really well. So we'll be able to measure like position and velocity,
Mm.
what the animal is doing. Cool, that was done. Then I wanted to know how it was doing that. So in a biomechanics lab, that's easy. You put the animal on oh sorry, a subject, I should say a human on a treadmill, or if you have a horse or some easier animal, you can put them on a treadmill and or let them run on a force plate. And then you can get your 3D motion capture, and then you can actually measure out like muscle moments, and you can figure things out like loading and all of that. But obviously with a wild animal like a cheetah, we can't bring it into the biomechanics lab.
Mm.
Um, and then I thought, okay, like what if I put a 3D force plate in the enclosure where the cheetahs are exercising? Um, which was a cool idea. But then I thought, okay, but the cheetah needs to run on this thing that's about 1 meter by 600 mils. How am I going to ensure that it actually hits on that? And I thought, okay, what if we make the area bigger, that it captures it?
Mm.
But then I'm sure many of you know that like 3D force plates are like $50,000 each. Um, so that was obviously impossible for my humble South African budget. So I came up with a new way of measuring 3D force using single axis load cells, and we
Mm.
patented that system. And the sports scientists were very, very excited about this, like more than anything. Because if you have a low cost 3D force plate, you can cover much larger area. You can put it on the side of a, football pitch. So like we actually spun out a company called Tech on that, and we are now selling 3D force plates. So
Mm.
um, it's really kind of like accidental journey into sports science, but yeah, I think it's been really fruitful so far.
Right. Okay. So I think one of the question is like if you have no access to cheetah at the time, what kind of animal that you want to work on rather than cheetah?
What animal would I work on if I didn't have access to cheetahs?
Yeah.
Ooh, difficult. I guess I'm really interested in motion, so stuff that's moving like really fast. Yeah, I had a small project a while ago where we were looking at like jumping spiders,
Oh,
and that was quite
Oh.
interesting because jumping spiders actually use the silk to stabilize their body.
Mm.
So one of my students built a robot where that jumped, and it could actually modulate the force a tension wire to then like reorientate its body. So yeah, definitely that anything that moves fast, I'm quite interested in.
Do you find that you hit limits with the materials that you can build the robots out of in terms of the strains that the cheetah's body or the jumping spider's body can go through? It must be quite difficult to actually reproduce those in a mechanical form.
Yeah, I know it definitely is a challenge. I should say we're not nearly close to what the cheetah can do. So far, like aluminium and just general CNC machining has been okay so far. But I think yeah, if we really want to push the limits, we would need to do some like carbon fiber or like injection molding things. Um,
Mhm.
that's a bit out of my scope of knowledge. That's like some deep mechanical engineering, but I do work with some really smart people who do composite
Mm.
material design and definitely something to look out for in the future. I actually have a PhD student now who's looking at the design of robotic feet, which is something not a lot of people are looking at, particularly for high speed running. And she's a mechanical engineer and she's looking into like various composites to do this. But yeah, it will be a
Is it the
constraint for the future.
jointing? How difficult is it to reproduce the joints? And
Yeah,
attain the flexibility and the motion.
yeah, it's a good question. Yeah, so maybe I should start by saying that like in my lab and my research vision has always been bio inspiration as opposed to like biomimicry. So what we set out to do is to kind of extract the principle of what's happening as opposed to just like directly reproducing everything in the real animal system. So for example, we have a robot called Kimba, which is as a quadruped robot, and we just soon to be published, have a spine on Kimba. So instead of us like actually, designing um, each vertebra with like some actual like flexible material, what we saw from the videos is that when the cheetahs are running really fast, they're just kind of trying to like decrease the distance between their front and hind legs and extend it as fast as possible. So what we actually ended up doing is put a pneumatic piston there, and that kind of replicates the motion quite well. We did a similar thing with the legs of Kemba where um, watching lots of videos and looking at the kinematic data, it looks like when cheetahs rapidly accelerate, they don't really finely control the force. They just kind of try and push off as hard as they can. So what we did was when we designed Kemba's leg is we also put a pneumatic piston there with an electric actuator on the hip for finer control. And what we showed is that with a very simple control policy, like just basically turning it on at a specific time and turning it off at a specific time, we're able to get robust acceleration again, just purely by extracting the principle of what we're seeing as opposed to, replicating the actual like biomimicry.
Mhm.
So, like to go on another topic, like maybe you already have seen this episode of Black Mirror in which there is this dog from type Boston Dynamics
Yeah,
starting
yeah, yeah.
to kind of take over the world, and it brings me to this question: is that like do you meet some resistance a bit like from general public when it comes to present robotic data? Because I imagine that for general public sometimes there's always this maybe misconception that robotic can be dangerous.
Hmm. I should say I myself have never experienced that. I guess there is also a large looming thing, I guess, particularly in the global south about, are these robots going to take our jobs? And where unemployment, especially in South Africa, is like a massive problem. Um, and I like to think of it like that, robotics isn't gonna make work go away, but there's going to be like new types of employment. For
Mm.
example, I always tell people that when I think it was in the 1960s, when navigation systems in aircraft were kind of like, matured, the role of a navigator in an aircraft, actually that job disappeared. But you can argue that it then made air travel much more safer, which meant that much more people were flying, more jobs for actually like building aircraft and running the entire infrastructure of aviation. So yeah, I think that um the robots won't like take away all jobs necessarily, but will probably make new kinds that we can't even imagine right now. For example, like if you told somebody 20 years ago there's going to be a job like called social media influencer, like nobody would even like. So I don't think we can imagine what's coming ahead. But yeah, sorry to come back to your point. Sorry, I'm rambling a bit, but I haven't received any pushback on for like, I guess, military fears, at least in the South African context. Yeah.
Okay. No, and I imagine that anyway, like for instance, in the case of your new innovation in which like you are combining AI and robotic in order to take picture of lion, for instance, and just like see whether like maybe they need a veterinary action. It's really opening something that will not be possible by a human at the moment, because I mean, I guess it will be possible, but obviously like if you were going as a human to take picture of the lion, you will sort of ruin the dynamic of the ecosystem at the moment. But like, do you have actually some data, for instance, on whether like these lion kind of don't mind about this robot passing around to take picture, or like
Yeah, are you talking about the system we did with the
yeah.
respiration? Yeah, so that system was actually was a Google funded system for doing very long range motion capture, and the idea was actually that we wanted to be as far away from the animal as possible. So myself and my longtime collaborator Andrew Markham from Oxford had this idea of, if we could measure what you can do in a motion capture lab but at like 150 meters away. And so we used a very long range LiDAR, which is essentially built for self-driving autonomous cars, and we combined it with a telephoto lens. So we were able to detect very far video, but also we can overlay 3D points on top of that from the LiDAR. And then we deployed it at Kgalagadi National Park in South Africa. It's one of our big national parks, and I've actually went to the first deployment with my students, and it's very, very fun. You drive around and you try and look for animals, and capture them. And on one of the trips, sort of by accident, we saw a couple of lions like sleeping in the road, and this is when we tried and we kind of like captured the emotion, whatever. And then we saw like we could actually detect the chest wall, as it displaced, and detect the amount of respiration that it's inhaling and exhaling. We could even detect when it was panting. So yeah, that's I think again a thing I didn't set out to do, but an interesting application. Because yeah, one of my like newer interests is on doing wildlife health monitoring. And I kind of got, I think like a lot of people got exposed to the idea of zoonotic diseases through COVID. And I discovered, through speaking to some ecologists and rangers at the national parks in South Africa, that, for example, lions get a lot of zoonotic diseases through something called spillback. So that's where they catch diseases from, like from us and our domestic animals. So lions can pick up things like rabies, canine distemper, and bovine TB. These are like really big problems. In fact, like I think 20 years ago, they lost, I think, 2,000 lions somewhere in one of the national parks because of canine distemper that kind of like spread through. And it comes from either like stray dogs, because maybe there are villages that stay close to the national park, or from cattle. So yeah, it's a big problem because they can only detect this when it's too late. Like they find a dead lion or they don't know like if it's spreading. So my new obsession right now is to design like systems where we can actually detect, if a wild animal is sick. And it's a very, very difficult problem. Like to be able to measure like heart rate or respiration rate or even like body temperature. But yeah, I'm hoping to be able to crack that in in the next chapter of my career.
Mm.
No, it's really actually fascinating. Like, so I will have to change topic a bit because like we don't have much of a time, and so I would
No,
like
it's
to sort of maybe refocus more on the career aspect
yeah.
of it. And like, because as I say, like at the very beginning, like this podcast, the idea is also like to sort of give some hint for new generation of researcher, like try for them to kind of learn from your own experience. And at this moment, like, what do you think will be important to say to an early career researcher? I mean, like, for instance, to tell them to keep in mind when they are exploring their options. Like, do you have any advice, like on how to just build up a career?
Yeah, no, this is a really good question and quite important to me, because I know this is an international conference that will hopefully be attended by many from the global south. And I spent most of my career, trying to be an academic in the global south, and it comes with a lot of challenges. So, it can be quite disheartening when you see, just the scale of funding that happens, sort of like orders of magnitude more than, what we can dream of in, the global south versus the developed world. So, but what I tell people often is, to look at what you have around you and leverage your constraints, right? Um, so the one way that I think the African Robotics Unit has done as well is to study problems we are uniquely positioned to solve. So for example, like studying things like wildlife, or my colleague Robin Verenda does, a research in the Southern Ocean, which is in Antarctica, where South Africa is one of the countries, and Australia as well. But one of the countries in Africa that has quite easy access to Antarctica. So it's really, she can get data that nobody else in the world can get. So I think kind of like finding those problems that you can solve easily, which others can't. And then yeah, like I said, the leveraging your constraints can sometimes be quite valuable. So like my problems I've spoken about before this now, of like wanting to measure 3D force, but it's too expensive. So, having to reimagine the way that you do certain things, I think kind of like forces innovation sometimes. And I think that is something that you should capitalize on. So yeah, I think definitely, yeah, what my message will be is that there is hope. You just need to
Mm.
kind of be smart about it, because you're not going to be able to compete directly with, a lab in the UK or the US with
Mm.
like 50 postdocs or whatever, and you're like this one PI in, I don't know, South Africa or Argentina or something.
Mm.
So yeah, you got to find your unique angle.
Yeah.
Well, and that's a great advice. I think it's good also to hear like this from young PI that there is hope, because like I imagine that for a lot of early career researcher, I mean, I'm part of it. Like from time to time, it can be a quite like
Yeah.
negative
Mm.
path, because like it's a lot of bump. But like I think it's important to just like keep going, indeed. And like from more of a PI perspective, and like so here, I think this question will be more addressed. I mean, to give like some advice to student themselves. Um, like what would you look for in a student? Like, I mean, what will be your advice regarding the best way to contact a lab? What will be like what are you expecting when actually a student is contacting you, and what will make you likely choose this person?
Mm. Oh, that's a good question. Yeah, I guess from my side, I guess on the logistic thing, getting a generic email from students. I mean, I get, especially now that I'm at UCL, like, wow, I get like every 2 days, I get a student contacting me with some generic email about like, that was clearly copy pasted and there's nothing to do with my work, but like, oh, I want to come to UCL, or. So yeah, I think like one, like aligning yourself with like and actually really engaging with what the PI is doing, in their lab, would be like be really beneficial, and seeing how you and sort of demonstrating how your skill set can, you know, aid that endeavor would be my best advice. And yeah, from my side, I'm always looking for students who are like really passionate about, um, you know, in my particular case, like kind of like bridging the gap between,
Mm.
robotics and biology. I often tell my students that, um, all the topics that I set, as PhD or master's topics, I love each and every one of them. And if I had all the time in the world, I would actually do them myself. So I'm a very invested, hands-on supervisor. I love being in the lab with students, working on problems together. So yeah, I would want people who are quite passionate and excited about the work. Yeah.
I am actually curious, like, so since you are, like you say, a bridge between robotic and biology, like, do you receive more application from student in biology or in robotic, or you manage to kind of, I mean, because I don't really know this field, so like how it works. Does it exist any master that already sort of do biorobotic or?
Yeah, well, not at where I'm based at the moment, but I think yeah, the overwhelming majority of my students have always been from engineering backgrounds.
Okay.
But it takes a special kind of, student to be interested in animals as well.
Mm-hmm.
Um,
Mm.
so yeah, I think it is quite a niche thing, um, to find a student who like, sees the value in, you're not just trying to make a cool robot, you're actually trying to understand
Yeah.
biology as
Mm.
well. So yeah, that is, I would love to have more biologists, honestly.
Okay,
Like
but
I
it's,
would,
it's
Mm.
cool to hear, I think, for people because, like, maybe some people sometimes are afraid to contact you because they are like, I don't
Mm.
have the engineering background, but
no, yeah, I would,
yeah.
I would, that is definitely something that I think is lacking. In my
Mm.
kind of like students that I have is a biological perspective, like
Mm.
like a trained biologist actually.
Mhm.
Mm.
We
Mm.
are like I'm also I often call myself sort of an accidental biologist, but like
Mm.
to have somebody with a real like
Mm.
a deep background in biology would be great.
Mm. Maybe I
Okay,
have a
that's
follow-up question. Yeah, for example, when you look in for the biologist, what kind of skill set that you are expecting
Mm.
from them?
Yeah, I mean, I guess it depends on the project, but I always am excited by people who do work in the field, um, because they understand, when you're designing systems in a lab and it's like, oh, it's nice and it works perfectly or whatever. But when you go outside, I mean, Tang, like, working outdoors is difficult. It's a different ball game. Um, and biologists who have done field work understand like, stuff goes wrong and you need to be able to
Mm.
kind of think on your feet. So yeah, that's definitely something I'm looking for. And then I guess like I have some projects also in, like on the modeling side. So if a biologist has like a computational background or mathematical background, that's like really really useful as well.
Right.
Do you think
okay. And
the variety of experience that you've had, the different areas, do you think brings a sort of valuable skill um, to research in that you understand more than one area and you've not singly focused on a particular area?
Yeah, I definitely think so. I think initially in the start of my career, like as just graduating with my bachelor's, because I did mechatronics engineering, which is like also a newish degree in South Africa. And employers were like, what is this? Are you an electrical engineer? Are you a mechanical engineer? Like,
Mm.
they didn't quite get it. And I was also like worried about that. But now I think I think it's really given me a good perspective on like kind of understanding, the kind of like interchange and interplay between different domains, whether it be mechanical and electronics or like actually, like biological and, electronics or mechanical so I think, yeah, that is definitely, I think, a valuable skill set to have is sort of this interdisciplinary um, thinking. Yeah.
Actually, I have a sort of follow-up question on that. Like, do you have the feeling that having worked Global South before give you another perspective of research compared to your colleagues in Europe at the moment? Like, because it's quite interesting to see, like, yeah, what is the vision of research on both?
Yeah, I mean, that's a good question. I would say it's a bit early for me to say, that I have an advantage yet, but I mean, I guess one thing that I've noticed already is that um, I'm used to doing a lot with a little. So, where people will say, "Oh, that's a small grant. It's like only, so many pounds," and I'm like, "What?" Like, so like I'm yeah, I'm used to being thrifty, and I'm hoping that's gonna serve me well.
Okay, that's good to hear. And like you also like because it's something that in animal behavior life is quite important. We are trying to reaching as much as possible every continent, and I must say that it has been a little bit complex with Africa so far. Like, did you have the feeling that when you were in South Africa, like there was less access to international conference, or like, yeah,
Yeah, 100%. Yeah, that is the biggest constraint I would say for researchers in Africa connecting with the world is like, okay, one, it's expensive, like
Mm,
to fly. I mean, like really like for us it was a big thing. I mean, I could only, as an academic even, I could only afford to go to a conference like once a year.
yeah,
Um, and then the second thing is the visas. Like, so visas are, I think, like really disproportionately affecting people in the global south.
hmm,
To attend these conferences, like many times we don't even bother because we know that it's going to be
too
so
long.
many months, you know.
Yeah,
So yeah, but I mean, so things are getting better now, I should say. Like, there was a really big machine learning conference that was held in Rwanda. So there's some guys at Wits, Benji Rossman, like his group is like really driving, sort of putting Africa on the AI map. And so there are more conferences like happening within Africa, which obviously means like attendance is much easier. But yeah, definitely, I think another thing which the ICRA, I mentioned ICRA before, is the International Conference on Robotics and Automation, has had these kind of like satellite events with the main conference, where it's sort of like either like a physical meetup of the local research scene, then it's affiliated with the main conference, or it's like live presentations of the talks to like a university. That's really that's very useful.
hmm.
Um, but yeah, no, so it is quite challenging.
So
Mm.
like you think that what is missing maybe is like actually as the example you just gave is that maybe some more international conferences are organized directly in Africa in order to sort of make global north come to south instead of the opposite.
Yeah, yeah, no, 100%. Like, and I mean, I've seen like such great reviews from people about the I forget the conference. I think it was either ICLR or ICML, which is like machine learning or reinforcement learning.
Mm.
Being in Rwanda, and there's also a big conference which was like a yearly thing that happens called the Deep Learning in Daba, which is like I think was started by
Mm.
DeepMind, Google DeepMind, and that also attracts many international people. But yeah, definitely, and it's what it makes so much sense because it will be so much cheaper
Yeah, yeah,
for
Mm.
global north researchers to come, and
yeah.
yeah. So for me, it's a no-brainer.
Yeah, no, but that's also why, like with ABL, we are trying to just furnish something fully online. But I guess it also comes with its own limitation, because I imagine that maybe like sometimes internet is not that stable. Maybe like I don't know. Yeah, like more technical limitation, let's say.
Yes, yes.
Okay, so like, I mean, we are pretty much arriving to the end of this session, but like I think we can go with what we like to do usually, like a sort of rapid fire questions. So
Okay.
like the idea is that you kind of have to not reply with just one word, of course, but like
Quick answer.
a quick answer.
Okay.
But like, believe me, nothing will put you on the spot. It should be all good. And then yeah, like we will be able to conclude this session. So okay, the first one, if you had to explain your research to a 10 years old in one sentence, how would you describe it?
Ooh. I guess I use robots to understand how animals move.
Okay. Looking back, what would you tell your PhD or postdoc self?
I guess don't waste so much time trying to get everything perfect.
If you weren't a researcher, what you will be doing now?
Oof. I guess I would just be an engineer in a company doing some control.
Don't forget dinosaur. Maybe you would actually do something with them.
Oof, that would be that would be great.
What is your favorite animal?
Well, yeah, the cheetah.
Cheetah. Coffee or tea while working?
Oh, coffee.
Coffee. If you had a magic wand, what would you change in research academia at the moment?
Oof, more money for researchers.
Okay, what was it? You did great.
Thank you.
So like, yeah, we like to finish like by asking you like if you have any recommendation. So it can be a book, it can be a paper, any resources basically that you have been in contact with recently, and that you would like to recommend to the community.
Mhm. I guess I can talk about my latest obsession, which I mentioned was kind of diseases and stuff. There's a really amazing book by a guy called David Quammen called Spillover,
Okay.
and it basically talks about how our relationship with diseases as humans has been like inextricably linked to wildlife, because all diseases must come from somewhere.
Mhm.
And whether it's like birds or like cattle or pigs or bats, it's really cool how everything is linked. And then I guess another book that I'm obsessed with right now is a book by an author called John Green, called Everything is Tuberculosis. And basically he talks about how throughout history, like everything is related to TB, and how even like today, it's still the disease that kills the most people, despite us having a cure for the last like 60 years because of wealth inequality. So I think that's very interesting.
So like reassure us, you managed to not get hypochondriac by reading all of this.
No, I'm not. I'm trying to solve the problems. I don't think I have the diseases.
Okay, great. Okay, well, thanks a lot. It was a
Thank you.
really inspiring discussion. I mean, your career is really nice and inspiring for people, I'm sure, who will listen. And I think for people who listen, it's also quite cool because you had a bit of a spoil of what we'll be presenting during the conference. So like, if you want to know more now, you know what to do. You have to register for it. So as a reminder, it will be the 13th and 14th of November, if I'm not wrong. Correct me, David Tang, if I am. Yeah, like Amir, like thanks a lot again for giving time for this, because it's I mean, in our opinion at least, super important to have the perspective of a PI because I mean, it's always nice to see science, of course, but it's also very nice to know what was behind. And it's not only about data.
Yeah,
Yeah.
thanks. Yeah, this was very fun. Thank you. I didn't know I was going to be able to speak for an hour, but I actually enjoyed
we
it.
were
you.
sure it will work. I mean, it's a format that we are doing now, I think, since 4 years. So we
Awesome.
kind of know that at actually 1 hour it's a bit short because let's be honest, we could have asked a lot of more questions. But yeah, thanks again, Amir.
Thank you.
David, Tang, thanks again for being here today. And that was it. Yeah. So
Awesome. All right. Thank you, guys.
Thank you.
It's
Hey,
nice to see you, and thanks for having
yeah.
me.
Meet the PI is presented by Animal Behaviour Live, an inclusive international platform bringing together animal behavior researchers across the world to discuss the latest research and question our academic practices. To know more, check our website at animalbehavior.live.